You are welcome in the part 2 of analyzing pattern videos, and in this part we will discuss about the high and low clustering. And here down something is about me. I'm Dr. Zubair Islam. I'm working in the Department of Geography at Gujarat University. So this is the calculation part of the general G statistic. And in this calculation, the important thing is here Xij and Wij. Xij, the I and J, Xi and Ij. These are the two means separate locations, and in each location I and J are the attributes value, and Wij is the spatial weight in between the feature I and J. So the spatial weight, there is some kind of conceptualization that we will see when we will practice with the help of software. And here Aj is not equal to I. What does it mean? That it indicates that the feature I and J cannot be the same feature. Okay, so thereafter this ZG score also is also developed with the help of this G statistic. And now let's see with the help of software. So our software is open here, and left hand side is the data and right hand side are the tools. Let me introduce my data. This data belongs to the Tigray region, and the data is at Tabela level, and there are many attributes here, but I will choose the temperature values. So let's see the pattern. What is the pattern of the Pebbles with temperature? So this pattern toolset give us the only the pattern details. While if you are interested in mapping, then you have to choose the mapping clusters. But this time we are talking about the analyzing pattern. And here we will talk about this high-low clustering with the help of this Getis or Journal G statistic. We'll open it, and we have to give our class here, and we have to give our field. There is LST temperature. I'm giving the temperature here, and I want to generate the report here. I will click. An important thing is, as we have discussed in the formalization part, that there is Wij. So this is very important, that what is our concept of the spatial relationship. So these are the options: inverse distance squared. So it's important actually, you have to think that how the features are interacting with each other in this space. The more accurate your results will be, if your concept is clear that how features are interacting uh, on the places. So your choice for the conceptualization of the spatial relationship parameter should reflect inherent relationship among the features you are analyzing. Sometimes your choice will also be influenced by the characteristics of your data. So if you see this inverse distance weighted, for example, are most appropriate with continuous data. Okay, continuous data means not discrete data. It is in continuous form, like maybe it may be a temperature data also, or to model process where the closer two features are in the space. So the important. So here, if I'm giving the inverse distance, then it is advisable to give some threshold also. Okay, because otherwise it will, if you are not giving the threshold, then there may be some, means the result may not be that much perfect. So when using the inverse distance conceptualization, you can give the threshold. This is optional only, but you can give. So a threshold distance will be computed for you, but this may not be the most appropriate distance if you are leaving it as optional. Okay. The default distance threshold will be determined, will be means it will be minimum distance that ensures every feature has at least one neighbor. So you can give the threshold distance. If you will see another method here, the fixed distance band. The fixed distance band method works well for the point data. It is the default option used by the hotspot analysis. When we will go for mapping clusters, there is the option here, hotspot analysis. In the hotspot analysis, the default you will get the default is the fixed distance band. Okay, this is the default one, though you can change, but this is the default for this tool. So it is often a good option for polygon data when there is when there is a large variation in the polygon size. Okay, so it may work well for the polygon data, and you want to ensure a consistent scale of analysis, then it is good. Another is the zone of indifference. Zone of indifference. The zone of indifference conceptualize work well when fixed distance is appropriate, but imposing the sharp boundaries on neighbor relationships. That is not an accurate representation of your data. Keep in the mind that the zones of indifference conceptual model considers that every feature to be neighbor of every other feature. So consequently, this option is not appropriate for large datasets since the distance band or threshold distance value supplied does not limit the number of neighbors, but only specifies where the intensity of a spatial relationship begins to wane. So the another option that is here, that is contiguity edge only, contiguity edge corners. So this contiguity edge corners, it is are effective when polygons are similar in size and distribution, and when spatial relationship are a function of a polygon proximity. So here polygons boundaries are important. Okay, so okay, so all these are the options which we can choose, but here let me choose this inverse distance. And what is the difference? Inverse distance squared means both are the same, but the difference is in inverse distance squared there will be a sharp curve, means there will be a sharp decrease of the weight from point as you will move away from the point. So let's see this inverse distance. And yeah, weight matrix file. In the previous video I have already talked about this weight matrix file. That weight matrix file you can generate with the help of a spatial relationship. Here, if you want, generate a spatial weight matrix. So computer will, based on the values and the location, computer will generate the spatial weight matrix, and that spatial weight matrix you can use here. That is also a very good option. So just make it okay here. So G score is here, that is, and P score is also, means it is highly towards. Let's see the result. To see the result, you go to geoprocessing and go to the results, and you will find the current high clustering and message. Direct, you can see the right click, copy locations, and you can, after copying, here, you can paste your location and enter. While entering direct, you can see the report in the word format. High-low clustering report, Z score, it is very much minus 1128. So, the clusters, there is three options here. Low clusters, I means three types of result. Your result is in minus 11, so you can see that minus 11 will lie in the dark blue part, okay, this part, and if it is here, then very low clusters are here in your data. If it is more than one and more towards this right hand side tail, then it will go your result, it will indicate that the clusters are high clustering is there, means there is a more number of polygons are clustered, making a large clusters, but here the clustering is low, and in between is the random pattern, means we cannot say it is low clusters or high clusters. So this is the general G summary. What is the observed, expected, then variance, Z score, P value, and this is about the data set, what we conceptualize. We conceptualize the inverse distance. Method is Euclidean distance, and distance threshold, which is taken by the software itself, is 21 kilometer here. So you can practice by increasing this threshold, maybe 30 or 40 kilometer. So the result is that here 1% likelihood, means the confusion is only 1%. The rest 99% you are confident that your result is low clustered pattern. So what you can formulate the hypothesis is that the distribution of temperature at Cavalli level is random. Okay, this may be your null hypothesis, and you can then, based on this result, you can reject your null hypothesis that this is not the random distribution, but this is low cluster, and you are 99% confident for that. So this was about the general G statistic with the help of GIS, and we will meet in the next video with another method, and in another method we will talk about the spatial autocorrelation. So this is a very important technique to analyze the pattern. So in the next video, we'll talk about this. So it's enough for this video, and thanks for listening and thanks for watching.